Okay, hey guys. You all have requested to do the submitting part of networking. This is just the submitting part. The whole networking lesson is quite big, so we'll do part by part. So before learning how to subnet, we have to know why we subnet. Okay, so let's first talk about IP addresses. So IP addresses are unique addresses assigned to each device on a network. Okay, IP addresses have a pattern. Okay, you can call it a sequence as well. An IP address is a logical address. It is not, you know, physical. It's always given logically into a device, whether it's a scanner, it's a printer, or it's a computer. It's given logically, like someone has to assign it through the switch or router. Okay, so the version we have in A levels is called IP version 4. Okay, there's another version called IP version 6. IP version 6 was developed because IP version 4 became how do you call it, people did not expect such an increase in the IT sector. So IPv6 was created. IP version 4 has only can hold up to about 4 billion computers, 4 billion devices, but IP version 6 can hold up to more. But we won't be learning about IP version 6 here, because in the A-level syllabus IP version 4 is only there. Okay, so IP version 4, it's 32 bits long. It's 32 bits long. It's divided into 4 groups with 8 bits. So it's 8 bits, 8 bits, 8 bits, and 8 bits. They are divided by a full stop, like a period, okay, by a dot. So we call this each set of bits an octet. Okay, so this becomes the first octet, this becomes the second octet, this becomes the third octet, this becomes the fourth octet. Okay, so there's two ways of writing IP addresses. You can write it with decimal numbers, which is easier for us humans. So you can write it like 172.16.254.1. Okay, this is called dotted decimal notation. Or you can also write it in binary, which is how the computer sees it. Most of the questions you get regarding subnetting will be from binary, so it will be easier if you can convert from decimal to binary really quickly. So 172 is 10101100 dot 16 is 1000 111 So this is called the dotted binary notation. So this is how IP addresses are written. There's this thing called slash notation. I'll come to that later. Okay, so moving on, each octet can go up from 0 to 255, or from 8 zeros to 8 ones, which gives us 256 numbers. Okay, so from decimal it can go to 0 to 255, and from binary it can go from 8 zeros to 8 ones. So there's 4 octets, so each one can go from 0 to 255, or 0 to 255, 0 to 255, 0 to 255. Okay, Okay guys, so moving on, each IP address, okay, IP addresses are categorized into 5 classes. The categorization depends on the first octet. Okay, so here we have a chart, the class first octet binary pattern. I'll explain these in a while. First octet decimal range, network mask bits, and network slash notation. Okay, so class A IP addresses, let's start with the decimal range because it's easier for us to know the decimal ranges, to remember the decimal ranges. Okay, so the the first octet decimal range of class A IP addresses, it doesn't start with 0, it starts from 1. And it goes on up to 126. Okay, so if you convert all the numbers from between 1 and 126 into binary, you will see that in each, if you take it in 8-bit format in which IP addresses are written, you can see that the first bit in all the binary numbers will be 0, the first bit. So that's how you can find a class A IP addresses when you are given binary numbers. Okay, so class A IP addresses, like you know what the subnet mask is? So the subnet mask is used to find the network ID from the host ID. Okay, so in each IP address there will be a network portion and a host portion. Network portion and host portion. This network portion and host portion varies according to what class they are in. Okay, so in group A, in class A IP addresses, the network portion will be the first octet in class A, and the host portion will be the second, third, and fourth octets. Okay, let's moving on. So back to class A IP addresses. So the network mask bits mean how many bits do you need to mask the network portion of the IP address. So in class A, we know that only the first octet has network ID, has network information in it. So an octet has 8 bits. So the network masked bits of a class A IP address should be 8. Okay, so the slash notation, the network slash notation, this is actually quite important because whenever you write an IP address, you have to write it in slash notation format, which means like here we wrote this IP address here, 172.16.254.1. we have to put a slash here, and then we have to write how many bits are covering the network ID. Okay, so back to this, we'll leave this blank for now. We'll move on to class B. So in class B, the octet decimal range, the first octet decimal range, it doesn't start with 127. I'll tell you why later. It starts with 128 and goes on to 191. Okay, so if you take all the decimal values here and convert it to binary, you will see that the first two binary bits will be 1 and 0. Okay, so in class B IP addresses, the network portion is contained by the first octet and the second octet, and the host portion is contained by the third octet and the fourth octet. Okay, so if the network portion is contained by 2 octets in class B, there's 8 bits in first octet and 8 bits in second octet. So the network mask bits will be 8 plus 8, which is 16. So moving on to the third one, class C. So the class C first octet decimal range will be from 192 to 223. Again, same way, if you convert all the numbers in between this range to binary, you can see that the first two numbers will be 1 and 1, and the second and the third number will be 0. So in the class C IP addresses, the network portion is contained by the first octet, second octet and third octet. Host portion is only contained by the fourth octet. Okay, so in class C IP addresses, you can see that there are 3 octets taken in to mask the network ID, to the network ID. So if you want to mask the network ID, you will have to have 3 octets worth of bits. That's 8 plus 8 plus 8, which is 24. It is 24 bits. Okay, so I'll write this as extra things, because if you want to go into the networking field, you will have to learn this as well. So this is just extra. If we get class D, it goes from 224 to 239, and the first four bits will be 1110. Okay, these are not needed for this. And class E, it will be 240 to 255, and the first 4 bits will be 1111. Okay, so that's out of it. So you can see in class A, B, C, going down from class A to C, the network portion increases. From going down from class A to C, again the host portion decreases. So class A can have only 3 octet worth of hosts, class B can have 2 octets worth of hosts, class C can have 4 octets worth of hosts. By hosts I mean different yeah. And for class C, there's only the 4th octet worth of hosts. Okay, so moving on to slash notation. Slash notation is what do you call it? Is written after the IP address, which is written in decimal format. So if you take this 172.16.254.1, it's in the class B range, no? So the class B range, again, it's from 128 to 191. So 172 belongs to that range. So in class B IP addresses, the default network ID, the default network bits are in the first octet and in the second octet. So in order to cover them, you would need 2 octets worth of bits. So that's 16. So by slash notation, what you do is you write the number of hosts, number of bits which are needed to cover the network portion. So in this case, since it's a class B IP address, you can write slash 16. That's the slash notation. So in class A IP addresses, the network mask bits, the bits needed to mask the network portion, is 8. So the slash notation will be slash 8. It's the same with the class B and C. So the bits needed to mask the network portion is ultimately the slash notation. So 16 slash 24, but you write the slash notation with the IP address. So if you take 192.168.1.1. You have to write the slash notation. In this case, it's a class C IP address. So the network bits will be on the first, second, and third octets, and so it's 8 into 3, so it's 24. If it was let's say 92.100.40.55, so it's 92, so it's class A IP address. Class A again from 1 to 126. So 92 belongs to class A IP addresses. So the network portion is in the first octet, so you need 8 bits. This part right here is the slash notation, and it's crucial you write it when you write the IP address in decimal form. You don't need to write it when you write it in binary form, but in decimal form you have to do that. That's how people and the computer knows how in what up to what bits the network ID portions are stored, the network information are stored. So moving along, there are two types of IP addresses, not the IP version 6, IP version 4 thing, but two types of IP version 4 addresses. There are public IP addresses and private IP addresses. So public IP addresses are the addresses which are used to browse the internet. So you can't browse the internet without a public IP address, and public IP addresses can't be duplicated, like two devices can't have the same IP address. But private IP addresses are the IP addresses which you give, which is a unique identifier for all the devices behind the router. Behind the router as in your network. Like let's say if you have a Wi-Fi network, the devices connected to that Wi-Fi network in your home, if the devices connect to that Wi-Fi network, will have private IP addresses. And then when you want to access the internet out of the router, then you will be given a public IP address with from your ISP. So in private IP addresses, however, two people can have the same IP address. Okay, so there are three ranges of private IP addresses. Okay, so the three ranges are 10.0.0.0 to 10.255.255.255. That's the first range. The second range is 172.16.0.0 to 172.31.255.255. They sometimes might ask these ranges, or if they'll give a IP address and they'll ask if it's a private one or a public one. So the third range is 192.168.0.0 to 192.168.255.255. You might notice if you had Wi-Fi problems, your ISP will tell you to write an IP address in your Google search bar, and it will probably be something along the lines of 192.168. something. So yeah, those are private IP addresses. So that's the range of private IP addresses, and everything else belongs to public IP addresses.